Okay, let's look at example 2.9. This is going to be the last example for chapter 2. In this example, you have this 200 kilogram uh, cylinder right here being held by these two cables, by a cable here and a cable here, and you're having a force P there which is pulling it away from the wall. So let's draw the free body diagram. Okay, so I'm tempted to just use a picture that is as it exists, but we need to get in the habit of drawing a free body diagram. So here we have our X, Y, and Z axes, right? And at this point right here, what do we have? You have 200 times 9.81. Remember, pounds is a unit of force. 200 kilograms is only a unit of mass, so you need to multiply by gravity. And at this point, you have a force P going off that direction. You have a force, I can call this TAC coming off in that direction, and you have TAB going off in this direction. So, what are our equations of equilibrium? Really, we're going to have sum of the forces in X equals 0, sum of the forces in Y equals 0, and sum of the forces in Z equals 0. So what do we need to do? We need to write all these things in vector form so that we can properly do this. So let's start with the easy ones. I'll call it, the weight is what? It's going to be minus 200 times 9.81 in what direction? In the J, it's minus J direction, right? So that's our weight. Our vector P is going to be what? It's going to be plus, it's just going to be the unknown magnitude P in the I direction. Now TAC and TAB. How are we going to do that? Well, big picture. TAC, the vector is going to be the magnitude times lambda from A to C, right? And same with the other one. So this is an unknown, so we need to figure out this. Okay, so lambda from A to C is what? It's the A to C vector over the magnitude of A to C vector. Okay, so what is the A to C vector? Well, it's going to go from A to C. In the X direction, it goes minus 1.2 I, right? In the Y direction, it goes from, it goes from 2 all the way up to 12, so it goes a positive 10 in the J direction. And in the K direction, from A to C, it goes this from here over to here, so it goes minus 10K. Okay, but again, that's the vector. We need to divide by its magnitude. So divided by square root of 1.2 squared plus 10 squared plus 10 squared. Okay, and we need to do that same thing for, so it ends up being, I'll just write down, I actually never wrote it down. Basically, this number ends up down here being from A for AC is 14.193, and then so therefore T from A to C is equal to TAC over 14 point, 193 times minus 1.2 I plus 10J minus 10K. And we're going to do the same thing for T from A to B. It's going to be T A to B over, it works out to be 12.86, and then just for sanity's sake here, it's again, we go minus 1.2 I, we end up going plus 10J, and we go plus 10K. And that's where that 12.86 comes from. Okay, so now we have everything nice and clearly defined. So let's come back to here. We want to take the sum of the forces in X, Y, and Z and set them equal to 0. And that's really, that's how you solve the whole thing, because you're going to have three equations. And what are our three unknowns? We don't know P, we don't know TAC, and we don't know TAB. So let's look at some of the forces in X. Sum of the forces in X equals 0. So what is that going to be? It's going to be, well, it's going to be TAC times minus 1.2 over 14.193 plus TAB times minus 1.2 over 12.86. And in x direction, we also have this plus p. Sorry, plus the magnitude p, because notice that it's not in the vector, it's just the magnitude, because we're just looking at the I portion of it. So that is one equation, right? And we take the sum of the forces in y equals 0, and we're going to get the same type of deal. Here we're going to have TAC. In this case, it's going to be 10 over 14.193 plus TAB times 10 over 12.86. And in the y direction, we also have weight, so it's going to be minus 200 times 9.81 equals 0. So that's equation 2. And then lastly, sum of the forces in z equals 0 is going to give us TAC times minus 10 over 14.193 plus TAB times plus, I put down 10. It's not 10, it's 8. Oh, I'm so sorry about that. This needs to be a big fat 8 and not 80. Just 8. Here, you know what? I'll make life easier. I'm going to actually erase that. Okay, this needs to be plus 8k, because it's going in this direction only 8 units. And so it's going to be 8 over 12.86. And in the z direction, that's all we have. So equals to 0. That's the third equation. So it's just a matter of solving for 3 equations and 3 unknowns. I'll let you look at the book or do it yourself. It works out to be that P is 235 newtons. TAC is 1238 newtons. And TAB is 1402 newtons. And that is your final answer. And so it's really not a hard problem. The gist of this problem, the main focus of this problem, what I want you guys to be comfortable with, is being able to do this. Define all your forces nice and clearly, right? So you have everything. You have a vector equation for all your forces, right? So I'll circle and make sure you have all of these. Once you have these, the rest of the math becomes pretty straightforward. It's not usually too tricky, but it's all about getting those equations and getting them right.